So in order for us to simulate this, we are going to increase the slippage to 10%. Why? Because that way we are able to have enough room to increase our profit. Then you can use this token IO, it's called IO, or Inu AI. In fact, I will give you the address here. Let me show you. This is a sample token that I've deployed. This is the address if you need it. It's called Inu AI. It's just a regular token. And yeah, I'm just gonna buy that token. Once I buy it, this bot will check the transaction. We'll go through all the checks. It will put every transaction in order and we'll send the bundle. So we go ahead and we swap this. Now we want to increase the reduce the gas cost in order to give it time for this to execute. So now we confirm it. This should receive the transaction in a moment. And it says that the victim will get less than a minimum. Maybe that's the case. In any case, let me show with the transaction after the checks are passed. We log in the transaction that we are passing. Let me reduce this, by the way, to 0.01. Yeah, this is for demonstration purposes. So now we click on swap. We swap that. It checks. This is the transaction that I've sent right here. It is checking everything, and it says that the victim will get less than the minimum. All right, guys, check this new project I've created. It's called MEV DAO, and it's simply a community where we will be building MEV tools. The Telegram link is t.me/MEV DAO. Let me log in everything here. This is important to convert to string to see all the data. Reload this, and instead of this one, let me use IO. This is another token that I deployed on goerli, and it has a bit more liquidity. So we deploy the transaction. It is captured right there. You see, this is the second buy amount. The minimum amount out is simulating, and we get an error. None's too low. What this means is that my transaction was confirmed before I executed all of these steps, all of the checks here. So we do again, we swap. This time let me reduce the speed by giving less gas. So this one got confirmed already. Let me try again. Check. Yeah, continue. These are other swaps, by the way. These are swaps from other people. Yeah, this basically, it says that it was confirmed too fast. Let me reduce this again. Let me do slow confirm. Okay. There you go. This is the simulation. These are the results. The simulation was successful. And the bundle has been sent to the miners. We now have to wait for the miners. This says bundle passed without inclusion. This means the miners rejected the bundle because it gave them too little value or whatever other reason. You see all of these simulations, these are other swaps from people. So this is a generalized sandwich MEV bot. It is also trying to sandwich transactions from other people. Again, we pass the simulation, everything looks fine. The bundle has been submitted, and again, we get that passed without inclusion. There are many reasons why that could be the case, but it doesn't really matter. We are gonna continue trying until we get at least one that is passing. Guys, as you can see, it finally was included. I had to try multiple times, but the bundle finally was accepted by the miners. The thing is, sometimes flashbots doesn't generate the block because they are a miner themselves. Sometimes they are not the ones building the block. Now the validators accept it, and he's the one responsible for the block. So if flashbots is not creating the block, they cannot include your transactions. That's why you will see many times where you are sending the bundles, but they are not being added to the final block, basically. So yeah, you gotta try multiple times, and I did like an hour trying to get this included, and it finally was included. As you can see, this is the simulation. We have all these transactions. So if we go to the from address, we go to goerli etherscan. You can see this is the address that sent the bundle. And there's 3 transactions. This is the first one, swapped exact ether for tokens. We are sending exactly 0.1 ether, which is what we define in the contract in the application. We're buying this many tokens. Then we are approving that many tokens. You know, it's in hexadecimal here. And then we're swapping back the tokens. As you can see, these are tokens we got, and we're getting this much ether. Now, as you can see, we're getting less ether than what we put in. We added 0.1 ether for the initial swap, and at the end we got 0.09, and that's because we haven't optimized program for profit. We haven't checked the numbers to make sure they're profitable. That's the case. Sometimes it happens, sometimes you don't make a profit, but you want to improve the application. The application that I've showed you before, it's a very simple thing that you need to build upon. You need to increase the complexity. You need to check the optimal amount that you should put in to get the least amount out for the victim, and improve the contract, the application that you're using, to increase the profitability and to work faster, because this code, it's very inefficient. It's very slow because it makes many requests to the blockchain. You want to remove as many requests from the blockchain as possible. In fact, I did on my advanced program that I've developed on my own front runner, and that took me about 2 months to develop. It was a long time because there are many issues that you got to go through. Now let me go through a few final indications, and these are the next steps that you can follow to improve this front runner, this sandwich bot. So you need to calculate the gas costs. Right now we are sending a fixed amount of gas using the bribe amount, but you want to make it so that you are sending an optimum amount, an amount that's using the base fee. You calculate the next base fee, you are sending the exact amount of priority fee and max fee. Like I said, max, the next base fee, that's the key. And then you want to calculate the amounts out locally. So instead of doing a Uniswap request for the get amount out function, you can do this locally. This is just a simple JavaScript function that should be the first step. Then you want to use multiple block builders, because flashbots, when you send your bundle to flashbots, they try to, to confirm it to create a block, but sometimes there's other block builders like Beaver, and there are a few others, and you want to send the bundle to them. It's possible that you can send the same bundle to multiple block builders. In fact, I'm sending every bundle to about 10 block builders, and maybe some of them includes the block or not, because they can be selected to become the next block builder, and you want to make sure your bundle is in that block. Now you want to reduce gas cost as much as possible. That way you can increase your profit and give more to the miners, which gives you a higher chance of being selected for, to get that bundle added to the block and make money. So for that, you need to write assembly UBL contracts in Solidity. That's the most efficient way. You need to go low level. Then you want to use multiple cores, and this is Node.js. You can use multiple cores to improve the performance, so that every transaction is sent to one of the cores and it's processed on that individual core. You want to calculate the transaction for type 0 and type 2 transactions. Sometimes you get type 0 transactions, so you want to also read those. You want to implement multiple dexes like Uniswap, SugarSwap, SushiSwap, and many others. There are multiple. And Uniswap B3, that one is a very interesting one, because not many people are doing front running, not many people are doing sandwiching on those exchanges because they're very complex. You need to develop a very advanced type of flashbot. Then you want to calculate the pair addresses locally. This is something that took me a while to find out because it's a bit tricky, but yeah, you can calculate the pair addresses locally and make them work. Instead of making a request that says get pair, you can do that with a function in JavaScript, which is extremely fast compared to that request. And the optimum amount you should send on the first trade to get the minimum amount out, so that the victim gets as small as possible when it comes to profit. And this is a very good thing that you should be looking for, because once you send the exact amount that you need to send, you are making the most profit. You're maximizing that. You can use a loop, or you can create a function. Now this is the most complicated thing, because you need to create a very complex function, and you need to be very familiar with how Uniswap V2 works. Now Uniswap V3 is a whole different story. It's a much more complicated situation, but on Uniswap V2 you can calculate all of that in one function. You don't need to make any requests or make any complicated calculations. You can just one function, you can understand how much you need to put in and how much you will get. This is extremely powerful stuff, and it took me a long time to develop myself. In fact, I had to pay a few developers and do a lot of research, but eventually I did. So I hope you found this content useful and go ahead and start working on this. I will leave the code in the description. And yeah, I'll see you soon.